Now let's shift our focus to data types that we use in statistical classification of data. So in statistics and data analysis, we classify data into four major categories. And this classification is crucial for determining what analytical tools we can apply. So the four categories are nominal data, ordinal data, discrete data, and continuous data. These categories are organized as shown in the diagram, with categorical or qualitative data on one side and numerical or quantitative data on the other side. The classification system is fundamental to risk management because different types of data require different analytical approaches. For instance, you can calculate an average of continuous data like loan amounts, but it doesn't make sense to calculate the average of nominal data like customer names. So categorical data includes nominal and ordinal. Nominal data consists of categories with no specific order, like customer types, individual, corporate, or government, or geographic regions. You can count how many customers fall into each category, but you can't rank the categories in any meaningful way. Ordinal data, on the other hand, has categories that can be ordered or ranked. So credit ratings are a perfect example. So AAA is better than AA, which is better than A, and so on. However, the difference between AAA and AA might not be the same as the difference between A and BBB, for example. Numerical data includes discrete and continuous data. Discrete data consists of countable items, like the number of credit cards a customer has or the number of late payments in a year. Continuous data can take any value within a range, like interest rates, loan amounts, or time periods. Understanding these differences is very important when selecting the appropriate AI algorithm and statistical technique for risk management application. Now that we understand what data is and how it's classified, let's explore how data is actually stored and organized in computer systems. So there are two primary formats for data storage: files and database. Files are electronic lists of data that are optimized to perform particular transactions or functions. Think of a file as a digital equivalent of a paper filing cabinet. It's a container that holds related information in a structured format. Files are often simpler to create and manage, making them suitable for smaller data sets or specific purpose applications. For example, in risk management, you might have a CSV file containing daily stock prices or an Excel file with customer credit scores. These files are straightforward to work with and can be easily shared between different systems or team members. Databases, on the other hand, represents a more sophisticated approach to data storage. A database is a collection of groupings of information that are related to each other in some meaningful way. The key advantage of databases is that they facilitate efficient retrieval, insertion, and deletion of data while organizing the information in structured formats like tables, views, and schemas. Databases are designed to handle complex relationships between different types of data. In risk management, you might have customer information in one table, loan details in another table, and payment history in a third table, all connected through a common identifier like a customer ID, for example. These structures allow you to perform complex queries and analysis that would be difficult or impossible with simple files. The choice between files and database depends on factors like data volume, complexity of relationships, and number of users, and performance requirements. Let's examine now the different types of files used in business and risk management applications. Each type serves a specific purpose in the data ecosystem. Master files store core information that is fundamental to the business or application. In a risk management context, a master file might contain customer profiles with basic information like customer ID, name, address, and primary account details. These files contain the golden record, which is the source of truth for key business entities. Lookup files contain static values that don't change frequently. These might include reference tables like country codes, currency conversion rates, or risk rating definitions. For example, you might have to look up a lookup file that maps credit score ranges to risk categories, such that 750 to 850 is low risk, 650 to 749 is medium risk, and so on. Transaction files store information that can be used to update master files. So this captures the dynamic activities in your business, like loan application, payments, account changes, or market transactions. In risk management, transaction files are crucial because they contain the behavioral data that drives many AI models. Audit files record before and after images of data as it changes. So these are essential for compliance and for debugging and forensic analysis. If a customer disputes a credit score change, for example, audit files help you trace exactly what happened and when. In regulated industries like banking, audit trails are often legally required. History files, also called archive files, store past transactions and historical data. These are gold mines for risk management because they contain the long-term patterns and trends that AI algorithms can then use to predict future behavior. A history file might contain years of payment that help predict default probability, for example. Each file type plays a crucial role in maintaining data integrity and supporting different aspects of risk analysis and AI model development. Now, let's explore databases in more detail. So a database is a fundamentally different form simple files from simple files because it's an organized collection of structured information that's typically stored electronically and managed by sophisticated software systems. A database is usually controlled by a database management system, or DBMS. The DBMS is the software that handles all the complex tasks of storing, retrieving, updating, and managing the data. Some famous examples include Oracle, SQL Server, MySQL. So here's what makes database powerful. The combination of the data itself, the DBMS software, and the applications that use them to create what we call a database system. This integrated approach provides features that simple files can't match. Things like concurrent access by multiple users, transaction processing, data validation, and complex queries capabilities. In most modern databases, data is organized in rows and columns within tables, similar to spreadsheet, but much more powerful. This tabular structure makes data processing and querying highly efficient. For instance, you might have a customers table with columns for customer ID, name, and risk score. And then you have another loans table with columns for loan ID, customer ID, amount, and interest rates. Now, the relational structure allows you to connect information across tables. So you can easily find all loans for a specific customer, calculate portfolio risk across different customer segments, or identify patterns that might indicate fraud or default risk. This organizational structure is particularly valuable for AI applications because machine learning algorithms often need to access and process data from multiple related sources simultaneously. What makes databases very powerful for AI and risk management application is the sophisticated data management capabilities.